Hello and welcome to your third science challenge. Last week and the week before that, we started our study of physics. The first week we learned about mass and what mass is. Mass is a measurement of all of the stuff that happens to be within a particular object. The more stuff an object has, the more mass it has. A good example of that is right here. I have two water bottles in front of me. One water bottle is empty. There's no stuff in there. Some air maybe, right? A little bit of air. This one it's full of water. This is a lot of stuff. This has more mass. And so that was the lesson the first week, was about mass and what mass is. Last week we learned about energy. And we learned that all matter has energy. It's made of energy. And that energy has two different types. There's energy that is in motion, that we call kinetic energy. There's energy that is resting and that is waiting to be acted upon, and that is called potential energy. Today, we're going to have some fun with gravity. Gravity is a pretty rad thing that exists in our world. It is a type of force. It is dependent upon an object's mass, and it is a force of attraction. The more mass an object has, the more gravity it has. Here on Earth, the biggest thing around is Earth, and that is why if you ever drop something, down it goes. It goes down to Earth. So today we're going to do a few experiments about gravity, and we're going to mess around with it a little bit. So the first thing that is really important to know about gravity is gravity is a measure of force that is attraction, that is being pulled down towards the center of Earth, and it acts upon different objects in different ways. However, all objects are attracted to Earth at the same rate of acceleration. What does that mean? Well, essentially what it means is that all objects fall at the same rate. There's one thing that can make objects not fall at the same rate. We'll get there eventually. But first, let's mess around with that. So this is going to be your first demo or your first experiment to do at home. What I want you to do is find two objects, any two objects that are roughly similar in size and shape. So for instance, I could use a tennis ball and a clementine. They're both about the same size and shape. And it's really simple. All I want you to do is drop them. I want you to try it a few times. Just go ahead and just drop them and see what happens. And every time you drop, assuming that you're dropping from the same height and you're dropping them at about the same time, they should hit the ground, or in my case the table, at about the same size, about the same time. That is because they're both falling at the same rate. Okay? So those are two objects that are about the same size, same mass. That makes sense. They should hit at the same time. Let's mess around with that though. Let's try some objects that have the same size, but different masses. So earlier I pulled out my water bottles and I showed you how one has more mass because it has water in it, and one has less mass that it's empty, but these water bottles are both the same size. What I'm going to do is I'm going to drop them. In theory, this one with more mass should fall faster, right? It's heavier. There's more stuff in there. Well, we're going to find out. I'm going to drop them in a second, but I just don't want to drop them on my table. I'm going to be using my beautiful Tom Selleck pillow. It's a favorite in our house. He kind of reminds me of someone. Anyway, I'm going to put this down on the table. We're going to drop our two water bottles at the same time. And hopefully they fall at the same rate and they hit this beautiful Tom Selleck pillow at the exact same time. Here we go. 1, 2, 3. Perfect. Okay, now let's have some fun. Let's try two things that have the same mass, piece of paper, but we're going to change the shape. Earlier we used two water bottles, same shape, right? We're going to change the shape. This one, we're going to crumple up. This one we're not going to crumple up. And again, you can try this at home if you want. All you need is two pieces of paper. And I'm going to drop both of these. Now, both of these have the same mass. And theoretically, they fall at the same rate, right? Because we said that. All things fall at the same rate. But you might notice something happens. Aha. All things accelerate by gravity at the same rate. But as things fly through the air, they smash into air particles. All over the place, all around us, there are molecules floating around. They're invisible. They're so tiny you can't see them, but they're there. I can prove it to you. Here's your second demo. All you need is, you can use a notebook, or you can use a book, you can use a board, a pizza box, whatever. What we're going to do is we're going to smash ourselves in the face with air molecules. All you need to do is you need to take your journal or your book or whatever you got that's nice and hard and just fan yourself. Oh, it feels so nice. Oh, it's great. My mustache is blowing in the breeze because I'm actually smashing air molecules with my notebook and directing them at my face. I've smashed myself in the face with air molecules. You can feel it. You can feel air molecules. So you know they're there. And as things fall, they smash into them. The more molecules that a thing bangs into, the more it slows. Every time an object hits a molecule as it flies through the air, imagine this is a part of air with all these little molecules. Every time an object falls through it, it bangs into these things. And as it bangs into these things, it has to push them out of the way. That takes energy. That takes energy that gets transferred from this to the little particles, and in doing that, it slows the fall of an object. The more particles it hits, the more the object is slowed. We call that property air resistance. Okay? Air resistance is a measure of how many molecules an object hits on its descent, and for each one it hits, it's going to slow its fall. That's why, if I drop my 2 pieces of paper, this paper is nice and wide. It's going to hit a lot of molecules as it falls. Whereas this one is all nice and compact. It doesn't hit as many. Now, here is your challenge this week. We're going to mess around with gravity, and we're going to mess around with air resistance. Now, we know that all objects want to fall at the same rate. We did experiments, we tried it out, check it out, they're all falling at the same rate. No matter what I'm dropping, they're all going to fall at the same rate. Now, the difference is when I have something that has a lot of air resistance, it slows the fall. Your job is to create something with a lot of air resistance to slow a fall. And specifically, you're going to be slowing the fall of a water balloon. So, folks who go to Breakwater, you guys and gals received a package from me in the mail with a bunch of balloons. I told you to save one. This is why. You are going to be blowing up your balloon to be about the size of your fist or so, maybe a little bigger. I made mine kind of big. And you're going to be attaching something to this device to create a high air resistance to counteract gravity. Now, if you can do that, you'll be able to drop this water balloon from a height and slow its descent, so when it hits the ground, it stays as a balloon and doesn't turn into a puddle. First off, I want you all to create something. Now, there's lots of designs that you can create, lots of ways that humans use air resistance to slow their descent and even fly. And so there's lots of options for you. Your first test, I want you to go ahead and test your object, whatever you build to slow its fall, test it maybe without the balloon, and test it from a short distance. And if that works, go ahead and try the balloon. And again, try short distance. And if that works, you can go higher. And if that works, you can go higher and higher. Just be safe and make sure you have your parents' permission and help. If you're going to do something like throw it out a window, that's really rad. But your parents need to know about it, and they need to help you with that. Okay? Go ahead and video your tests if you want to, or if you want to take pictures of your device, that'd be awesome too. Your parents or you can send them either to me or to your teachers. If for some reason you don't have a water balloon, maybe you don't go to Breakwater and you're seeing this online somewhere, or maybe you used your water balloon for something else last week, that's fine. You can do this same test with a piece of fruit. You'll get similar results. Will you smash the apple or not? If I drop this apple from here, it's gonna get a little smushy. If you want a real level up and you want like superhuman challenge, you can try this with an egg. Remember, we're not patting the object from the fall. We're trying to stop it from falling at the normal acceleration rate of gravity. So that's your science challenge for the week. Have some fun with gravity, have some fun with air resistance. Make sure you get some pictures or video. Send them in. We'd love to see it. I'm excited to see all your creations. And I'll see you all next week. Have a good one.